Well, this is the second video for Math 60 in the unit that we're doing on algebra and solving equations. And so this one will extend those ideas that we talked about in that first video. In the first video, the problems that we saw, we either had to do adding and subtracting to cancel things out and solve, or we had to do multiplying and dividing to cancel things out and solve. Okay, so now we're going to take it a step further, make it a little bit more complicated, where we have to do a little bit of both. So let's take a look at problem 2 as an example and talk about how to approach solving these problems. So 3x plus 1 equals 6. And this is, I think, a good example of the kind of equation where your intuition may not be strong enough to see the answer right away, right? When we say x plus 4 equals 10, you can just see x is going to be 6, right? Here, it's not so clear, and if you start plugging in numbers, because that's also a strategy that people use to solve equations, here, it's not going to be that helpful to you, okay? And I'll talk about why that is in a minute, and you'll probably see, because the answer is not going to be a whole number. So if you just start plugging whole numbers in there, you're not going to find the answer. That's why these methods of solution can be so helpful. So, the idea here is that we're going to have to do some of both. The adding and subtracting to cancel things out, and the multiplying and dividing to cancel things out. So, first thing that I suggest that you look for in these problems is find the piece that has the variable that we're looking for. Okay? The x is here, it's getting multiplied by 3, then we're adding 1, and we're getting an answer of 6, and those two sides are in balance with each other, right? Here are the two sides of the equation. So, my suggestion about solving these equations is to first get this piece by itself, and then after that, we can worry about getting the x by itself, okay? So to get this piece by itself, we need to subtract 1 on both sides. That's pretty straightforward. Minus 1, minus 1. These cancel each other out. This side, we're left with 3x. Over here, we're left with 5. Okay, now the 3 is getting multiplied by the x, and so we can do the opposite of multiplying by 3, which is dividing by 3. Those cancel out and leave us with 1x. Over here. So this is why I was saying that this problem can be difficult to solve just using your intuition, is because the answer is not a whole number. It's 5/3. You can call it 5/3. You can call it 1 2/3. You can call it 1.6 repeating. But again, if you're going to use this decimal form, put a bar over the repeating part. Okay. So that's my suggestion for solving this problem, is to always look for this piece, get this piece by itself first, and then worry about getting the x by itself. Now, one of the great things about mathematics is that you don't always have to use the same order of steps that I use. And I think that that's really a beautiful thing about mathematics. In fact, I had a professor once who grew up in the Soviet Union back in the 1970s and 60s. And somebody asked him once why he liked math so much. He said it was the only class where I could do something different from the teacher but still be right. And I think that that's a beautiful thing about mathematics, okay? Is that you can do something different as long as it's mathematically valid and still get the right answer. Now, I'll show you why I recommend this method rather than what I'm about to show you in a minute. So, what if you said, I want to divide by 3 first, right? That 3 is getting multiplied by the x. Why can't I divide by 3 on both sides? You can. Here you go. Now, the trick is that you have to divide this whole piece by 3. You can't just go in and divide this one by 3 and leave this one alone. You've got to divide both sides by 3. Well, over here, we get a 2. That's pretty straightforward. What about right here? Well, if you remember back to when we were doing the distributive property, right, where we had like 2 times y plus 7 is 2y plus 14, in the explanation for this, I talked about why you can distribute multiplication over addition and subtraction. You can also distribute division over multiplication and subtraction. And so that's what's going to happen here. We're going to get 3x over 3 plus 1 over 3. Okay? So here, these cancel out. But now we've got x plus 1/3 equals 2. Subtract 1/3 on both sides. And there's your 5/3, 1 2/3, or 1.6 repeating. This is usually more complicated, but there's nothing wrong with it, okay? It's just a little bit trickier to understand and do correctly. So, when I'm doing these problems, I'll continue to talk about this method right here, but I don't want you to think that there's some reason why you can't do this. You can, okay? You can make different choices and still get the same answer. All right. Oh, let's take a look at a couple more here. What else? Let's look at problem 6. Here we've got 5 plus 2x equals 50. And so again, you can see the x is here. It's getting multiplied by 2, so the first thing we want to do is get this by itself by subtracting the 5 on both sides, right? This is a positive 5, and so we want to subtract 5 on both sides. That'll give us 2x equals 45, and then divide on both sides by 2. And you can call this 45 over 2 if you want to. There's nothing wrong with that. If you divide 45 divided by 2, then you should get 22.5. Either one of those answers is fine. You can call it 22.5 as well. Okay, let's see here. What else? Problem 8. We've got 10 equals 1 plus 4x. And so again, this is very similar to problem 6. Okay, we're going to subtract 1 on both sides. And that'll be 9, and then divide by 4 on both sides. And again, you can call this 9/4, you can call it 2.25, or you can call it 2 1/4. They're all the same thing. What else? What else? Well, let's look at problem 10. Here we've got negative 5x minus 7 equals 48. So, our x is over here. It's getting multiplied by the negative 5. So we want to take this negative 5x and get it by itself. And to do that, we want to add 7 on both sides. So these cancel out and make 0. Over here, we get 55. And then to get the x by itself, we want to divide on both sides by negative 5. So this all cancels out, leaves us with 1x, because that's always what we want. And then over on the other side, we get negative 11. So x equals negative 11. Now, the next problem has it has some similarities to the last two that we saw, but there's this one important difference that people sometimes don't pick up on. So, now, when we were talking about combining like terms and doing the order of operations, I talked about how the sign for a number or a term is always in front of it. This negative sign is connected to the 2x, okay? So this is a negative 2 times the x. The 3 doesn't have anything in front of it. That's a plus 3. Okay? So, if we want to get this minus 2x by itself, we're going to do that by subtracting 3 on both sides. These cancel out and make 0. Don't lose that negative sign. This is minus 2x equal to 14. And then to solve it, we'll divide on both sides by minus 2. And that'll give us 1x equal to negative 7. Okay, so sometimes what I see, so what's so tricky about this problem is that sometimes what I see people do is they see the 3, they see the minus sign, and they say, oh, right, I'm going to add 3 on both sides, and that gives me 2x equals 20. That's not correct. I know some people say that math teachers should never write something that's wrong on the board just because if people see it, it goes into their brain as being right. This is not right, okay? So that's what I'm saying, is that this negative sign is attached to the 2. The 3 is a positive 3, that's why we subtract 3 on both sides. Please don't fall into this trap right here, okay? All right, what else here? Problem 14, now we get into some that where we've got fractions. So problem 14, we start out with 1/3 x plus 7 equal to 12. Same approach. We're going to get this 1/3 x by itself first by subtracting 7 on both sides. That'll leave us with 1/3 x equals 5. And then you can divide by 1/3. Like I said, there's nothing wrong with that so long as you calculate it correctly. And if you do 5 divided by 1/3, you should get 15. What I'm in the habit of doing when I see this is to multiply on both sides by the reciprocal, and that gives us the same answer. Okay? Either one of these methods of calculation is correct. Okay. What else? Problem 16. So this is 6 minus 2/3 x equals 13. So again, this has that same situation where this minus sign or negative sign is attached to the 2/3. The 6 itself is a positive 6. So if we want to cancel out that 6, we're going to need to subtract 6 on both sides. So those cancel out. Don't lose that negative sign. It's attached to the 2/3. And so we come out with negative 2/3 equals 7. And again, same thing we did over here. You can divide on both sides by negative 2/3. And that'll give us, what is this? X is equal to negative 21 over 2. Pretty straightforward. Negative 10.5 or negative 10.5. And the other thing you can do here is to multiply on both sides by the reciprocal. Negative 3 over 2. This all cancels out. And over here, there's your negative 21 over 2. Okay? So it's essentially the same process. It's just one of them is handier where you don't need the calculator. Because if you were going to calculate this yourself, you'd have to multiply by the reciprocal anyway. But if you're doing it on a calculator, there's nothing wrong with doing 7 divided by negative 2/3. Your calculator should come out with one of these two answers. They're the same number. Okay, let's see here. Let's look at 18. Here we start out with 12 equals negative 6 minus 5x. Okay, now in this problem, over here where the x is, these both have negative signs attached to them. Okay, so if we want to cancel out this negative 6 or minus 6, then we're going to add 6 to both sides. So those cancel out. There's our minus 5x. Over here, 18. And then to solve this, we want to divide on both sides by negative 5. That all cancels out. Here, if you want to call it negative 18/5, that's fine. That's a correct answer. It's in lowest terms. If you want to go ahead and divide this through, I think we're going to come out with negative 3.6. Okay. Alright, over on the second page, we'll look at a few more of these. Problem 22, we start out with 65 equal to 2 minus 9x. So again here, recognize that this minus sign is attached to the 9. This is a negative 9 getting multiplied by the x. Here, the 2 doesn't have anything in front of it, so we know it's a positive 2. So if we want to cancel that out to get this minus 9x by itself, subtract 2 on both sides. Don't lose the negative sign that's attached to the 9. Over here, 65 minus 2 is 63. And then divide on both sides by negative 9. And your x should be equal to negative 7. Problem 24, we've got 3/8 x plus 10 equal to 7. Okay, so we don't have to worry about signs here, about positives and negatives. This is a positive 3/8, this is a positive 10. Okay, so if we want to get this piece by itself, subtract 10 on both sides, so this cancels out and we're left with 3/8 x. Now over here, be careful when you're doing your subtractions. 7 minus 10, that will take you over into the negative numbers and give you negative 3. And then again, divide on both sides by 3/8, or multiply on both sides by 8/3. In either case, let's see, what do we come out with here? Looks like we should get negative 8. Okay, see if you take 3/8 x and then multiply on both sides by 8/3, the 3's cancel out and we're just left with the negative 8. Okay, problem 28. Got 8x plus 7 equal to 1. And again, this is a problem that's typical of why we use the methods of solution rather than guess and check. Okay? You can sometimes guess answers, and it is sometimes helpful. It is less helpful in a situation like this. Okay? So let's use the methods to solve it and see what we get. We've got a positive 7 here. That means we want to subtract 7 on both sides. 1 minus 7, negative 6. And then divide on both sides by 8. And so negative 6 over 8 is not in lowest terms, so if you want to leave it as a fraction, it'll be negative 3/4. If you want to do negative 6 divided by 8 on your calculator, you'll get negative 0.75. Both those answers are correct. Either one is fine. Okay, what else? One more here, problem 30. What do we start with? 80 plus 5x equal to 9. So, we want to clear out this 80, cancel it out by subtracting 80 on both sides. That'll leave us with 5x here. Over on this side, 9 minus 80, that should give us negative 71. And then we'll divide on both sides by 5. And let's see. Now this is lowest terms. If you want to call this negative 71 over 5, that's right. Okay, there's nothing wrong with that answer. It's fine as it is. If you want to do the division there, let's see, what is that going to be? I think it's going to be negative 14.2. Okay, I'll double check myself on that one. So, 71 divided by 5, negative 14.2. There we go. Okay, and you can call it negative 14 1/5 if you're partial to mixed numbers. Nothing wrong. These are all correct answers. Okay, so you can see how we've gotten sort of away from those problems that are kind of simplistic and easy to solve without actually using the techniques of algebra. And so now we're combining the problems where we have to do some of both of these, okay? And so I think it's really helpful to understand how these processes work. So As you're working through these, please let me know if you have any questions about it. I will get quizzes for these up and posted this week, and we'll talk about it later. Thanks. Bye.